Go! Okay, so we are on solving absolute value equations and inequalities. So first question is, what do you remember about absolute values? Landry.
Yes.
Okay.
It's like a number's distance from zero.
Distance from zero. Okay. Also called a magnitude. Distance from zero. Okay. So what else does that tell us? Is it Ava? Okay.
Always positive.
It's always going to be positive. Okay, and again, because can you have a negative distance?
No.
No, you can't. So therefore, it will always be positive. Okay, so when we solve absolute value equations, such as this first one here, where we have the absolute value of ax plus b is equal to c. So what's happening is, if you think about our number line, because as we said, we are talking about a distance from zero. So let's say that our point ax plus b is over here. And then we're saying if we measured the distance between them, it would be c. But that's only going in one direction. So we would also have to look at the opposite direction. So that would be coming back here. And so rather than ax plus b, it would be negative of it. So negative ax plus b. But again, the distance here would still be c. So what ends up happening is we get two separate equations. The first equation being just like it's written in the first place, ax plus b is equal to c. The second equation is going to be that negative, the opposite direction. So ax plus b equals c. Right. And then usually what I do is, rather than trying to solve this and distribute that negative to that binomial there, I just move it to the other side. So what ends up happening is you get, bless you, ax plus b is equal to negative c instead. So two equations that we're going to solve. All right, and then we've got exclamation point here. Always check for extraneous solutions. Who remembers what an extraneous solution is? What's that?
Like a weird solution.
Is it weird?
It's extra.
In what way? Extra in what way?
There's two solutions.
Okay, so in these we are going to find two solutions, but the question is, do both of them work?
No.
Not necessarily. Sometimes both work, sometimes they don't, okay? So the extraneous solution, it's one of those, when we solve the equation, algebraically, we will get a solution to it, but we have to look at the original problem. So when we plug it back into the original equation, it's not going to make any sense.
So always check it.
Always check. Yes. Okay. So these always make more sense when you actually do one. So let's start with our first one. The absolute value of 3x plus 9 minus 10 is equal to negative 4. Can anybody tell me what is the first thing we should do? Oh, I'm trying to remember names. Okay, you have to help me.
Julia.
Julia. Okay.
Move the 10 to the other side.
Move the 10 to the other side. And why do we want to do that?
So we can get the absolute value by itself.
Get the absolute value by itself. So we're going to move 10 over, which will give us the absolute value of 3x plus 9 is equal to 6. All right. And so again, we know one distance. We've got to look at the other direction as well. A question, Annie, or?
No, I have the next step.
Okay, what's our next step?
divide by 3.
Can we divide by 3 yet?
No.
What do we need to do first?
What are the absolute value?
Okay, yes, we need to get rid of the absolute value first. So we have to look at the directions both ways from our number line, from our 0. Okay, so our first equation stays the same. So 3x plus 9 is equal to 6. But what's our other equation going to be?
Negative 3x plus 9.
Okay, negative 3x plus 9 is equal to 6. All right. So I'm going to solve the first one first. They are all divisible by 3, so we could reduce it. I'm just going to go ahead and just solve by trying to get my 3x alone here. So I'm going to move the 9 to the other side. So I'll get 3x is equal to negative 3, which means this x is equal to, what do we get? Negative 1. Okay. So for the other one, again, I don't want to distribute that negative sign, so I'm just going to move it over. So that becomes a positive. I get a negative there. So now, if I move my 9 over, I'm going to get 3x is equal to negative 15. So this x is equal to negative 5. All right, so I have 2 solutions. Do you have a question now?
Wait. I don't understand why you did the second one.
Which one?
The second, like, all of that.
This here?
Yes.
Okay, because remember, we are having to consider what's going on in this direction as well. And we're starting from 0, and we're going the same distance, but in the opposite direction. So that means we're going to have the negative of that value.
Wouldn't it be that, like, it would be like x equals positive or negative 1?
No, because we have 2 separate equations we have to solve for. So you have to create 2 equations. And so this equation solves to x equals negative 1. There's not a square here to undo. And then this separate equation gives us the x equals negative 5.
Okay.
Yeah, so 2 separate equations. Alrighty. Again, we want to make sure we don't have an extraneous, so we have to check in the original equation. So checking, I have the absolute value of 3 times negative 1 plus 9 minus 10, and we're trying to see, does that equal negative 4? All right, so I have negative 3 plus 9 is positive 6. Absolute value of positive 6 is 6 minus 10. Does that equal negative 4? Yes, so that one checks out. And we'll also check our other answer of negative 5. So the absolute value of 3 times negative 5 plus 9 minus 10. And again, we want to know, does that equal negative 4? So we have negative 15 plus 9 is negative 6, but the absolute value of negative 6 is positive 6. So we again get 6 minus 10. Does that equal negative 4? Yes. Okay, so both of those check out. So we have 2 solutions. X equals negative 1 and x equals negative 5 are both solutions.
So you just plug it back in to check? Or?
Check in the original one.
Okay.
Yeah. Okay. Ready to look at the next one?
No.
No? Shrink that a little bit so we can at least see it. Alright, so let's look at B. I have 4 times the absolute value of 2x plus 7 is equal to 16. So again, what's the first thing we should do? divide by the 4 so that we can get the absolute value by itself. So dividing both sides by 4 will leave me with the absolute value of 2x plus 7 is equal to 4. Okay. And so again, we are looking at the 2x plus 7 being a distance of 4 from 0 in both directions. So our first equation will be the 2x plus 7 is equal to 4. And what will our second equation be?
Negative 2x plus 7 equals 4.
Okay, so if we did the negative on the outside, yes, and then just moved it over. So I'm just going to skip that one step and turn that into equals a negative 4.
Oh, equals a negative 4?
Yeah, it's the same thing as what we did here, but remember I just moved the negative over so I don't have to distribute it through.
Okay.
Okay, so solving the first one, I get 2x is equal to negative 3. So that means this x is equal to negative 3 over 2. And our next one, we get 2x is equal to negative 11. So this x is equal to negative 11 over 2. Okay, and I know nobody likes the fractions. Yes, Elle?
So if you know that you have to make 2 equations, is it okay that you put the negative and then like when I did it, I did like for absolute value of 2x plus 7 equals 16, and then negative 4 absolute value of 2x plus 7 equals 16. Will that always work?
No, I always isolate the absolute value first. Okay. Yeah, always isolate. Okay. Can we stop here?
No.
Nope. We've got to check into the original, make sure it's okay. So we have 4 times absolute value of 2 times negative 3/2. And who's already cringing because of the fractions? But that's okay, because look what happens in this one. The 2's divide out. We're left with negative 3 plus 7. Oh, let me put my question mark up here. Okay, negative 3 plus 7 is 4. Absolute value of 4 is 4. 4 times 4 is 16. This one checks. And our other one, 4 times the absolute value of 2 times negative 11 over 2 plus 7. Does that equal 16? And again, those 2's will divide out. Negative 11 plus 7, negative 4. But the absolute value of negative 4 is 4. And again, we get 4 times 4. And does that equal 16? Yes. So in this case, again, we have 2 solutions. X equals negative 3/2 and x equals negative 11/2. So how are we doing so far?
Okay.
Okay.
What can I do this extra?
Yeah. Okay. Here's our next one. Absolute value of 3x plus 1 is equal to negative 5. Any thoughts on this one? Yes, Landry?
Is there no solution because it can't equal a negative distance?
Exactly. So these are the ones you get excited about. You're like, yes, don't have to do any work here. Okay. This is no solution. Oh, that looks really messy. Let's try that again. And again, absolute value cannot be negative. All right, so tell me, what would happen though if you didn't catch that right away and you went ahead and you set up 2 equations. You set up 3x plus 1 equals negative 5 and 3x plus 1 equals positive 5. Would you get 2 solutions? No.
Yeah.
You would. You would get 2 values of x. But again, what do you have to do with your answers?
You plug it back in.
Check them. What would happen when you went to plug them in?
It won't work.
Okay, neither one of them would work. And at that point, because what happens sometimes, when you're like rushing through homework or a test, you just get in that solving mode, and so you don't really stop to think, and you just start going and going. So usually you do that once or twice, and you realize how much time you just wasted in solving an unsolvable equation, and then you don't do it again. But it happens to everybody. Okay. So if you catch it, especially, if you solve both and then you check them both and neither work, then you start thinking, oh, I must have done something wrong and, in the arithmetic. But again, always think about the original, what's happening there. Okay, I have one more absolute value equation to do with you. All right. So the absolute value of 2x plus 12 is equal to 4x. And so what changed in this one?
There's an X in that.
So we got one on the inside and one on the outside. Does that change how we solve the problem? No, does not change anything. We're going to go through the same process. Let's see. I'll go back to that one. All right. So again, we are going to look at, and again, the absolute value is already isolated for us. So we just start with the 2x plus 12 equal to 4x. And then what will my other equation be? Equals negative 4x. 2x plus 12 equals negative 4x. All right, so again, we're just going to solve both of those individually. So the one on the left, I like to keep my x's positive, so I'm going to move the 2x over to the right side so that I get 2x over here is equal to 12, which means this x is equal to 6. All right. For the other one, I'm going to move that negative 4x to the left to make this one a 6x equals negative 12. So this x is equal to negative 2.
Wait. Hang on.
Yes.
Okay, so did you move?
I added 4x to both sides in this one.
And you moved the 12.
And I moved the 12 to the other side.
Oh.
Yes. Yeah. So put that in there. I did 4x plus 4x, and then minus 12 minus 12. Okay. I just prefer it that way so that I don't have that negative x. Okay. Are we done?
Now we have to check.
Yes, we have to check. All right, so I go in here and I set up my first one. I have 2 times 6 plus 12. Does that equal 4 times 6? All right, 2 times 6 is 12. 12 plus 12 is 24. Absolute value of 24 is 24. Does that equal 4 times 6?
Yes.
Yes. That one checks. So we're good to go there. And I check the next one. I get 2 times negative 2 plus 12. And does that equal 4 times negative 2? And what do we see? Yes, Ava.
Well, there's going to be a negative on the after equal sign, and the other side only has absolute value, so it can't work.
Yes. So even without solving this, we already know this side has to be positive. This side is going to be negative. There's no way for that to equal each other. So what does that tell us about x equals negative 2? Which is called an extraneous solution. So we know that does not work. It's out. Our only solution is x equals 6.
So that happens whenever there's a negative number?
Not necessarily.
Okay.
Yeah. So, there's different cases. So don't automatically assume that because you got a negative, it doesn't work.
Okay.
Yes.
So how would that look on a graph?
On a graph, well, we only have one solution here, so it would only be, okay, so if we thought about this in terms of a graph, this side would be like y equals 4x, which is what?
I'm sorry.
What if I put it like this?
Oh, that's the slope.
Yeah, so that would just be a line, and this one is also y is equal to absolute value of 2x plus 12. So what that would mean is that where is the only place those two would intersect? At when x is equal to 6. Yeah, that would be the only place. Okay. Right. So now let's move into the inequalities, okay, which are very similar. Okay, so the only thing that's changing here is rather than being equal to a value, we are looking for an interval of values. So again, very similar here. If I set up a number line here, and again put 0 here, and if I said ax plus b is over here, and because it's a less than, that means I'm going to have an open circle at ax plus b. But the distance between 0 and ax plus b is still c. Okay. But I'm interested in the values that are only less than c, so that would mean it's everything in here. And just like with the equations, I also have to look at the other side. So again, if I had negative ax plus b on this side, and we'd open that circle again. So this distance here again is c, but we're interested in the values that are less than c. So again, it's everything in here. So we have an interval of values between those 2 points. For the greater than c, what's going to change? What's that? Again, this distance is c, but what values are we interested in? The greater than, so that means I would be interested in everything happening out here. And same thing over here. If I do the negative of that, again, this is the c, but I'm interested in everything greater than that distance. Okay. So this is where that interval notation is going to come into play again, like we did over there on the board. Okay, because we're going to have sets of solutions like an interval where it's either going to be between the 2 points or going against those 2 points. All right, so we've got sort of a long way to solve these, and then we've got sort of my more shortened version that I like. I'm going to show you both ways. Just so that you understand what really what the process is. Okay. Right, so don't feel like you need to write all this down because this is all posted for you.
Even your notes that you're taking now?
Yeah. Yeah, I post a hard copy of all of it. Okay. So in the first method, what happens is we get rid of the inequality sign, we turn it into an equal sign, which means we just have an absolute value equation, which we just learned how to solve, yeah? So we've already done those. But again, because the values that we are interested in are not the ones that we are solving for, so like these would be the zeros, we're not going to test those points in particular because those points are on the border, okay? So what we're going to do is test values that are to the left, right, and in the middle of those, okay? And when we say test them, we say like a sign analysis because we don't even necessarily have to solve them out completely to see whether or not the statement is true or false. We can kind of do it kind of quickly to save some time. Okay, so that's going to be the longer way. I'm going to do the first one the longer way, and then I'm going to show you sort of the shortened version. Okay, all right, so let's look at the first one. Again, we're starting with absolute value of 3x plus 2 being less than 5. Right. The absolute value is already isolated for us, so we don't need to do any preliminary work. But now we're going to go ahead and change this less than sign to an equal sign. So we have 3x plus 2 is equal to 5. So now this is just like the equations we solved a couple minutes ago. So I get two equations again. 3x plus 2 is equal to 5. What's my other equation going to be? To negative 5. So 3x plus 2 is equal to negative 5. All right, so solving for each of these, I get 3x is equal to 3, or x is equal to 1. And this one will be 3x is equal to negative 7, or x is equal to negative 7/3.
Wait, negative, oh yeah.
All right. But since I started with an inequality, what I have to do now is think about my number line here. I'm going to mark 1 over here, and I'm going to mark negative 7 over 3 here. And does this have to be to scale?
No.
No. Just need to have them in the right order. Okay. All right, it's a less than sign. So when I'm going to mark these 2 points, do I want an open circle or a closed circle? Open circles. All right. So I've essentially divided my number line into how many regions? 3 regions. And so now I need to pick a point in those regions to test. All right. So looking at my negative 7/3, which is the furthest to the left, what's a nice, easy value to the left of that?
Negative 1. Or wait,
Negative 2.
I would have to go to at least negative 3. Okay. Negative 1 will be in here. Negative 2 will be in here. So we want to do negative 3. All right. So we're going to plug the negative 3 into the original equation. So we have the absolute value of 3 times negative 3 plus 2. And we're checking to see, is that less than 5? So I get negative 9 plus 2 is negative 7. Absolute value of negative 7 is positive 7. Is that less than 5? No, this is a false statement here, so I'm going to put an X over on that side. Next region is between negative 7/3 and 1. What's the nice easy value there?
0.
0. Okay, so anytime you can test 0, use it. Okay, so we get the absolute value of 3 times 0 plus 2. And again, is that less than 5?
Yes.
Yes, this one checks out. This is true in here. So what should happen when I test the region to the right now?
It shouldn't work.
It should not work. Okay, you shouldn't end up with 2 of the same 2 regions in a row matching. So it should not work. It's still a good idea to check that third region, because sometimes what happens up in here is you make a little arithmetic error and you don't catch it until you get down here and you're like, hold on, something's not adding up. Okay, what's a nice easy value to the right? 2. All right, absolute value of 3 times 2 plus 2, is that less than 5? It is not. Okay, so that's a good sign. All right, so our final thing is, we know it's this region in here. Can we put that into interval notation? Yeah, what's our interval going to be?
-7/3.
-7/3 is the beginning. Does that have a hard bracket or a soft bracket on it?
Soft.
That's a soft bracket. And continues until 1 with a hard bracket or soft? With a soft bracket. There we go. Yes. Yeah. Okay, how do we feel? Nervous? This is tedious. Okay, I'm about to show you a quicker way. It's a quicker way, but you have to be careful. Okay. So, our next one. All right. Absolute value of 5 minus 2x greater than or equal to 1. So, same rule applies. Make sure that your absolute value portion is isolated. It's already isolated for us here. Does the problem make sense? If we take an absolute value of something, can it be greater than greater than positive 1? It can be. Okay. So therefore, we'll go ahead and continue. Now, the little trick that I do, I'm looking over here at this positive 1. What would be the opposite of that? -1. So I'm going to put my -1 on this side, and I'm going to repeat this symbol. The symbol is greater than or equal to, so I'm just going to go greater than or equal to, and 5 minus 2x greater than or equal to 1. How many inequalities do I have? I still have 2 inequalities. Okay, I've got 1 here, and I also have 1 here. And I have to solve each one of those individually. Okay. So I'm going to start with the first one. -1 is greater than or equal to 5 minus 2x. Okay. So again, I'm going to move that -2x to the other side because I don't like working with negative variables. So that becomes positive 2x over here is greater than or equal to. I'm going to move the -1 to the other side, so that's going to become 6 over here. Okay. What would happen if I left the -2 on the right side and ended up having to divide by a negative? Yeah. You're going to have to flip the sign, which is probably why I always do it this way, because how many of you forget to flip the sign? Yeah, that's me too. I forget to flip the sign, so therefore it's better for me just to move the numbers. Okay, so in the end, this is going to be x is greater than or equal to 3. So there's our first one. Now I'm going to move to the other one, which is the 5 minus 2x is greater than or equal to 1. So again, I'm going to move my 2x to the other side so that it's positive. So 2x is over there now. Move the 1 to the other side. This becomes 4. And so now this is x is less than or equal to 2. Okay. And I know we read left to right. So when I read this, it says 2 is greater than or equal to x, which I cannot visualize in my head. I can't wrap my head around that, so I just flip this around so that it looks like this instead. Do they mean the same thing? Yeah, they mean the same thing. It's just much easier for my brain to comprehend the x being smaller than 2 versus 2 being larger than x. Okay, So if I think about my number line again, I've got 2 here. I have 3 here. There is a greater than or equal to, which means included. So I want to put solid circles, and that's on both of them. They both have that. Okay, now if I look at, let's look at the purple one first. X is greater than or equal to 3. What side should I be shading? To the right of 3. That's over here. Okay, now if I look at the green portion, X is less than or equal to 2. Where should I be shading? To the left of 2. Okay. Do we have to do a test point?
Yeah. No.
No. That's what's nice about this method. We don't need to do test points. Okay, what's our interval?
Hard bracket 2, 3.
Okay, so remember,
Okay.
is 2 to 3 is not included.
Okay.
Yes.
So do hard bracket or soft bracket.
Soft bracket,
infinity,
negative infinity.
comma, 2 hard bracket, and then you do another one. Hard
With
bracket,
a union in between. Yes, hard bracket
3,
to
comma,
infinity.
soft.
Soft bracket. Okay, so we only have a couple minutes left. The last 2 problems I was going to have you guys do up on the board with partners. We don't really have enough time for that. So what I will do is I will solve them out on this video here, and then I'll post the video this afternoon. So if you feel like you need more practice, you can look back and refer to that.
Where will it be?
On the Okay, so these are the last 2 problems that I had the classes do up on the board. So what I will do is put the solution down. So if anybody wants to go back and try them, you can check your work. So for C, we get the interval of negative 14 over 5 to 2. And for D, we end up with negative infinity to negative 4 union 5 to infinity. Okay, so if you want to try those again, you can check your answers, and if you're confused, come back and see me.